So today our speaker is Yannay Spitzer from Hebrew University of Jerusalem, co-authored with Ariell Zimran, who is also among the panelists today. So Ariell should be able to handle some of the questions that you may ask. Yannay is an economic historian. Most of his work is anchored in history. And a good part of it is also dealing with migration issues. So today, this is very much at the crossroads between migration and economic history, very typical of Yannay's work. The paper, as you can see from the shared screen, is like an int blot on paper, which may not be self-containing in terms of title. So we have the subtitle, Testing the Diffusion Hypothesis of Mass Migration, Italy, 1876-1920. So what is called the age of mass migration. So Ariell, the way we organize the seminars is that we have more or less 45 minutes for presentation and 15 minutes for discussion. The panelists can interrupt you, and also the moderator. So Simone can also direct some of the questions received from the chat messages to you. Okay, so the floor is yours for these 45 minutes.
Okay, so first, thank you very much for inviting me. It looks like a pretty amazing organization, a huge opportunity for us because we often speak with historians, but we do read and cite a lot of migration scholars in economics. I think almost all of them are here, really, and it's I didn't expect that in advance, and it's just great. So this is joint work with Ariell, my co-author, a follow-up to our previous paper about the on the selection of the Italian migration to the United States, but based on a lot more data on overall immigration from Italy over a period of more than four decades. So let me start, if it works. Okay. So, so this figure kind of explains the motivation of what is the question that we're trying to answer. What you see here is year by year during the period that we refer to as the age of mass migration, the source composition of American immigration. And you see here a phenomena that probably you're all familiar with, which is up until the 1880s, 1890s, the vast majority, the overwhelming majority of American immigrants came from Northwestern Europe. So countries like Great Britain, Germany, Ireland, Scandinavian countries, they comprised 80 or even 90% of all European immigrants to America. And then over a short period of time, mainly during the 1890s, the source composition completely switches, such that by the years leading up to World War I, we have 2/3 or even more of the immigrants coming from the European periphery. So these are primarily from the multinational empires of Southern and Eastern Europe, such as Russia and Austria-Hungary. And the largest single source country is Italy, which is 20 to 25% of all immigrants at that time. So we know that those countries were far poorer, both nominally and in terms of real wages, relative to the Western European countries, even relative to Ireland. And so the question here is really, why is it that the poorer countries of the European periphery came so late into the cycle of mass migration?
Just a precision, Austria is not today's Austria, right?
No, it's the Habsburg Empire.
And it's mostly Galicia and parts of which, I mean, that would be nowadays Poland.
So there are lots of Poles, Slovaks, Czechs, Jews, some Germans, but it's a multinational empire, and usually the minorities are those who migrate. And the same is true for Russia. Very few ethnic Russians are moving. We're actually going to focus on Italy today, but I think that the phenomenon is continent-wide. So we have, if we had a cross-section comparison of real wages and emigration rate, we would see that in the first decades, up until around 1900, it's actually the wealthier countries that are sending relatively more immigrants. And then it switches very, very sharply. So the question is, it's a big question in the economics of the period, why this switch happened. If those people in the periphery were so poor, why is it that they didn't move before? When we know that when they got to it, they actually did it in very large numbers. So we're going to refer to this question as the delayed migration puzzle. Okay, the late arrival of the European periphery to the cycle of mass migration to the United States and to other destinations. So what we're trying to do in this paper is to advance an explanation for this puzzle. Okay, the explanation that we consider to be at least the dominant view in the literature, if not the consensus view, puts it on, let's call it delayed development. Okay, so there are many versions to this theory, but all of them say in one way or another that in order to produce mass migration, a country needs to overcome certain thresholds. It could be that previously it was too poor and there are liquidity constraints that are overcome, and then it can fulfill its potential. We'll get to a few of those explanations later on, but that's kind of like the gist of all of them. Alternatively, there is another opinion in the literature that is, we think of it as a minority view, which says that basically the delayed migration was a result of a diffusion process. So places that had the potential for mass migration, for example, Southern Italy or Galicia or the Pale of Settlement in Russia, would have produced migration. The incentives were there, but the networks were not there. And it takes time for migration networks to filter across space. So first, migration networks do move across space in an orderly way, and it takes a lot of time. And some regions can get stuck behind, not for a few years, but for a few decades. And that this is the main explanation for why those regions are not producing mass migration until they finally do. And when they do it with very large numbers. So I'll give some more details on how we compare those two hypotheses. But let me move on and say what is it that we actually do. So we're talking about a European-wide phenomena, but we actually can only focus on Italy. And what we want to show is that there actually was a diffusion process in Italy in the post-unification period. So what we do is to bring in new data, a commune level panel and a district level panel year by year on Italy for over 4 decades. We're going to present a theory. It's going to be kind of more verbal and hand-wavy, but we actually have a robust theory behind it. And we're going to show that there are certain predictions that are going to follow from this theory, and we're going to test those predictions. And eventually we're going to show that the mechanism of spatial contagion, that migration in one place is inducing migration in its neighboring places. We will show that this mechanism actually applies in reality. The mean of migration in Italy, we think that the geographic trends of emigration coming out of Italy. So in terms of economic significance, we think that this is the first order thing and not other explanations that were brought to the table. We see diffusion processes that are destination specific. So we're going to see that the diffusion process of migration to Europe is different from that to the United States, and it's different from that to South America. We think that we have very good evidence that whatever is diffusing has to do with social contacts, okay? So there are certain things that we cannot really nail down. It's not going to be a complete proof of the theory, but we think that we can at least nail the diffusion down to things that have to do with social contacts. Okay, so now we're going to contrast in a little bit more detail the two conflicting views, okay? So the consensus view, which we're going to refer to as the internalist view, internalists because fundamentally it argues that the timing of migration is explained by internal causes, okay? So in one way or another, as I said, the theory is that mass migration is driven, or basically is jump-started by modern development. It could be about liquidity constraints. It could also be about other processes that have to do with economic and demographic modernization, such as the demographic transition, or increased urbanization, or industrialization. So basically, the story is that a dormant pre-industrial economy cannot produce mass migration because either people are too poor, or they're attached to the land, or they haven't moved to the cities, which things are much more mobile. Then when these processes arrive, which was first in Great Britain, then in Germany, and only much later in the south and in the eastern parts of Europe, when this happens, there things start to move around, and people find themselves able and incentivized to move abroad. Summing it up, we think of Tim Hatton and Jeff Williamson's book as kind of like the canonical presentation of this view. So according to them, mass immigration in Europe had to await the forces of industrialization at home and the glut in the mobile age cohort driven by a demographic transition that industrialization produced. So we think that there are a number of problems with this internalist view. So for example, if you think about Ireland, mass migration far predated industrialization. It even predated the famine, okay? And there is no evidence that there is any demographic pressures to speak of that explain the timing of the beginning of the Irish migration. In my previous work on the Russian Jewish migration, there was, I think, very strong circumstantial evidence that there was a diffusion process. We see an early migration belt that is highly concentrated. About 5% of the territory in which Jews live in the Russian Empire is producing 99% of the migrants. But then it starts to move. At the beginning, it looks very orderly, like a moving wall. Then it gets a bit more messy. And the pioneering regions are probably poorer. So that's not consistent with any sense of kind of like an economic modernization that starts this process. Generally, if you look across European countries, it's really a riddle that there is no strong and consistent within country correlation between development and regional rates of emigration. Yes, Petra.
So you're talking about diffusion. So can you already tell us like what type of diffusion? Is it like knowledge or is it actually money?
We think that it's personal contacts, but I will really get to that when in a couple of slides when I get to the theory. I'll have a very concrete example.
But is it personal contact where I actually support them?
Yeah.
In the country when they come? Okay.
Yeah, we think that information that is not based on social contacts is insufficient to produce this process. Okay, in the case of Italy, it was already pointed out that what some writers refer to as the standard model simply doesn't work. It doesn't explain the destination choices. And if you look at like the regional panel data variation of Italian immigration, it doesn't make any sense. It has nothing to do with the process of industrialization, that's for sure. We're going to see it in the maps very soon. On the other hand, the diffusion hypothesis was offered by social historians. Economists always struggle to deal with diffusion. It was actually the historians who brought it. And in some countries, there is anecdotal evidence that this is really what's happening. In Scandinavia, in Spanish migration to Argentine, as I mentioned before, in the Jewish migration from the Pale of Settlement to the United States. And John Gould, an economic historian who published a series of wonderful papers in the late 70s that really summarized everything that was known about the age of mass migration, kind of a precursor to Hatton and Williamson, argued in one very long article with lots of anecdotes and examples, and I thought it was quite a convincing case that we cannot understand the age of mass migration without diffusion. And he uses Italy as the canonical case. Okay, so in a way, we're kind of following up on this paper that was written 40 years ago and never really got into the consensus. The idea was not widely accepted, never systematically tested. It was not tested, we think, because there was no clear theoretical framework. It requires fine, high-resolution data that did not exist until recently. And the evidence up until now was mostly anecdotal and informal. So just to contrast the different views in the literature, this is Jose Moya, a historian of the Argentinian migration. We kind of ripped off the title of the paper from this quote. The contagion of immigration spread over the map, much like an ink blot on paper. John Gould had it that the great upsurge in immigration from South and East Europe was caused by the progress of diffusion of immigration in potentially immigration-prone areas, the achievement of saturation level in which occurred almost simultaneously in the 10 or 15 years before the outbreak of World War I. You already see the concept of saturation, and we're going to show that it happens and talk about it. What is saturation? Saturation is a state in which the option for migration is fully diffused. Everybody basically already has a link abroad and can choose to migrate if he wishes, okay? And at that point, when regions reach saturation, this is when the rates of migrations are stabilizing. Hatton and Williamson, on the other hand, completely rejected offhand the concept of the diffusion of migration. They argue that it offers few empirical predictions and says nothing about why immigration rates eventually decline. Now, we think that that's not a fair description of the problem and of the ways to resolve it. We think that there's actually ways to test it, and this is what we're trying to do for the first time in this paper, to provide a quantitative systematic assessment of the diffusion hypothesis as far as it relates to the post-unification Italy. Okay, so this is more or less that's the introduction. In terms of the theory, I'm not going to show any equations. I'm going to do it verbally and show a diagram that kind of shows you what we have in mind. The theory is basically epidemiological in nature, or a combination of a push-pull model with an underlying epidemiological model of diffusion, okay? So we think that fundamentally, we do agree that at least the model assumes that people do react to push-pull incentives as in the standard way, okay? But in order to respond to incentives, individuals must have a link, okay? So a prior link is a necessary condition for migration. So you can kind of think of migration as a technology that diffuses between communes and between countries and regions. And once someone has this link, it's as if he has the option to use that technology. And then he can solve his migration problem. He can decide whether he wants to migrate or to stay. But as a first order approximation, if you don't have a link, it's impossible to migrate. Okay, it's a strong statement, and I'm going to make it weaker later on. Okay, but just to kind of like the crystallized ideal version of our model, let me walk you through this diagram that kind of like explains what we have in mind. So what do we have here? So we have three communes: commune A, commune B, and commune C. Okay, and person A1 in commune A is sort of patient 0. Okay, in this diagram, we consider him a pioneer. Okay, so what is a pioneer? I said before that a linkage is a necessary condition for migration, but a linkage can be spontaneously produced. Okay, if someone migrates without a forward link, without knowing someone who to help him abroad, then we considered him as a pioneer, someone who was able to spontaneously receive the option to move. But once he migrated, he is linked to two people in the same commune. These are person A2 and A3, who now have the option to migrate. And after a while, in this example, they're indeed migrating. And as they migrate, they provide the option for migration for further people in the same commune. So this is a process of intra-communal diffusion, a linkage that is produced within the commune. Now, person A3 in commune A is also linked to person B1 in commune B, okay, which is a nearby commune. And by migrating, he created the option for person B1 to move. So this is a case of intercommunal diffusion. And we think about the diffusion process as one in which first migration diffuses within the communes and then across neighboring communes. And the commune C in the far right is a commune that is not near commune A. There are no personal link, yet C1 is a person that spontaneously created himself a link. And he may choose to migrate if he wants to. Now, in order for the diffusion hypothesis to work within this context, we need two things. First, we allow for pioneers, but the rates of arrival needs to be sufficiently small. And second, personal contacts across communes become increasingly rare as the distance rises. And very long distance contacts are very rare. Without those two assumptions, we cannot produce our outcomes with our model. So these two assumptions are crucial. And in a sense, our empirical testing is to show that actually those two assumptions are likely to hold. Okay, so now let me compare the standard model of the standard model being one in which people react push-pull incentives, and networks are sort of cost shifter. So if you know more people abroad, it's cheaper for you to migrate, but there is no dimension of inter-communal diffusion. So both versions recognize the significance of migration networks. I don't need to tell you that. Everybody who works on the economics of migration knows that networks are important and are the #1 predictor of migration. That's not the news that we are coming in here. We also both agree that fundamentally the individual decision is subject to the standard push-pull incentives, real income differences, etc. The place where we differ from the standard model is in the answer to the question, what happens in the absence of migration networks? According to the standard model, and Hatton and Williamson actually say it explicitly, if the incentives are right, then pioneers will very soon jumpstart a chain migration. Okay, it may take a few years, but not a lot. And so networks take a short time to build up. And also there doesn't need to be a transmission between neighboring communes. In our story, so long as pioneers and long distance links are rare, the prediction is that migration could await the arrival of networks, and that could take a very long time. And when we say long time, we're talking about 2, 3, and even 4 decades, an entire generation. And those places that are stuck behind, because there is no availability of migration networks near them, actually do have an underlying demand for migration. It's a pent-up demand. And it's released at once within a short number of years, exactly when the migration networks arrive in the vicinity of their communes. Okay, so from this theory, we can produce 4 predictions, and there's also a mechanism that we need to show that takes place. So first, we have the prediction that there's going to be convergence in the rate of migration. This already shows up in John Gould's paper. Convergence of both type, both beta and sigma. Okay, sigma convergence in the sense that the variation in the rates of migration across geographic unit is diminishing over time. This is because we have a major source of variation, which is the lack of availability of networks that is gradually removed over time. Beta convergence in the sense that places that are producing no migration at all are going to catch up. Okay, so we're going to see places where migration is established that are going to be on a flat trend, whereas places that are stuck behind and are not producing any migration at all or very little migration are going to increase the rates of migration very, very fast. The second prediction is the usual prediction in the diffusion technology, in the diffusion of technology literature, which is we're going to see S-curves of adoption of migration at the local level. The third is the frontier effect. We're going to show that migration is jump-started precisely in the areas that are at the frontier of migration. Okay, places that are the nearest, places that have already contracted migration, but beyond them there is no migration. These are the places that are in every period are the ones that are going to pick up. Finally, the fourth prediction is that the destinations of the migrants is going to be more correlated as the distance between the two provinces or districts or communes is diminishing. Two closed places are going to have the same composition of destinations simply because they have the same menu of migration options, because they share the same links, or they're on the same migration networks. And the last thing that we're going to do is to show the mechanism, that there really is a causal effect of migration in the proximity of a commune to the migration in the commune itself. For that, we have a novel IV strategy, which we kind of like, and we think that it could become useful for any context of spatial diffusion of anything within social context. Okay, so a brief description of our data. We are relying here, the first time this data is fully compiled, basically a panel of migration of over almost four decades and 8,000 communes between 1884 and 1920. At the level of the district, and we have 280 districts, we can take it back even to 1876. And at the level of the province, we can have a migration matrix by 28 destinations. Okay. So just to be clear, when we speak about migration from a commune to a destination such as North America, there's a little bit of interpolation here because we only know the distribution of destinations at the province level. And so we need to impute it internally within the province. It's not something that's going to create us a big problem, we think, but it's just something that I need in mind. The data are based on passport issuance. Okay, so it's not really migration data. It's in order to migrate legally from Italy, you needed a passport at that time. And a data point is a passport that was issued. There are problems with that, okay? So there is a distinction between temporary and permanent migration. We found it completely useless. So it's just an exit of an Italian. It doesn't tell us that he's left in the first time. On the contrary, we actually see evidence, especially in migration from northern Italy to neighboring countries up in the north, like Austria and Switzerland and France. We see evidence that people repeatedly do it many, many times. And sometimes 10% of an entire commune is written as having migrated. So there are issues with this data. I don't have time to get into them, but overall, we judge them to be good for our purpose.
So if I understand this correctly, you do have very good data on return migrants. Is that correct?
Not as good as that. It's not at the level of the commune. We know departure, we don't know returns.
But you said they're going repeatedly.
Oh, we know that because the number, there are certain communes that over the period of 40 years, we see the ratio of total migration to the population, the ratio is 4 and more. So it's got to be the case, and 10% a year sometimes. Mm-hmm. So this is really seasonal migration across the border. It's not going to create a huge problem for us. It's not so frequent in the United States. American migrants are, so Italian migrants to America, on average, I think they travel about twice. Mm-hmm. Okay, so now I'll show you the maps. Before showing the predictions, I think the maps themselves, I hope that they will change your priors. They're not a proof or anything, but you can see a lot of what's going on in the maps, and the predictions are just kind of like confirming what we do see in the map. So these are the districts of Italy. For the district, as it said, we have data going all the way back to 1876. And we see that there are a couple of epicenters from which migration to the United States starts. And I'm going to unravel half decade by half decade the rates of migration. So this is 1876, 1881, 86, 91, 96, 1901, 1906, and 1911 to 1914, the last years before World War I. Okay, so what you see is that it may not be perfectly clean, but there is a pattern that you can see in the eye where starting from some epicenters, migration is spreading in what looks like sort of concentric circles. You can see it much nicer when you look at the commune level data. They remind you that there is some interpolation here, but it's not what's driving the pattern. This is 1884. Okay, we see 4 clusters, one in Liguria, one in Campobasso in the center south, one in Calabria, and one around Palermo. And I want you to look at around here, around Messina, which is the northeastern tip of Sicily, a place that at the beginning produced no migration at all. And over time, migration advances and captures it. And by the time that we reach what we call saturation, these places send some of the highest rates of voluntary international migration ever observed in world history. So why did Messina not produce any migration at all in 1884 and moved within 20 years to being basically a world leader in mass migration? We think that it's really about the time that it takes migration to move from either Western Sicily or from Calabria into the northeastern tip of Sicily. And the same example could be replicated in many other places in Italy. Yes?
How do you get to the United States from Italy? Where are the ports?
Genova, Napoli, and Palermo. These are the ports of departure. We don't think that the ports themselves play a very important role, but if they did, it would be consistent with our story.
Yannay, just one quick remark on your example of Messina.
Yes.
In 2008, there was a major earthquake that caused major disruption in the city. So if you make this example, and
yes.
I think it's going to be a distraction.
Yeah.
You're spoiling the story, Simone.
Yeah, let me just say that you're most welcome to read our paper on the migration around the 1908 Messina earthquake,
Yeah,
which we're soon together with Gaspare Tortorici. Thank you for that. Yeah, but it's not about the earthquake. I mean, it picks up just before the earthquake, like 5 or 10 years before. And let me move on to showing you the patterns. This is simply puts the sigma convergence. Almost monotonously, year by year, we have a very sharp decline in the measures of the variation in the rates of immigration across Italian districts and across Italian communes. Okay, it declines over the period in almost an order of magnitude. Okay, and then you can see that in the 10 years before World War I, it stabilizes, which is consistent with the story of Italy reaching saturation at that point. This is beta convergence. Okay, on the horizontal axis, you see the average annual rate of migration of Italian districts between 1876 and 1899. And on the vertical axis, you see the change in that rate after, the proportional change in the rate after 1900. And notice that both scales are logarithmic. So what do you see here? You see that there is a very strong negative curve, which tells you that places that produce very little migration or no migration at all are just catching up with the leaders, whereas the leaders are staying stable. Okay, so this is really the process of catching up. And an interesting feature here is that in no place is there a decline in migration. Okay, it's really surging and stabilizing. Okay, the district with the least increase in the rate of migration is still increasing by a little bit its rates. And as you go to the left, and again, it's logarithmic, just look at the numbers, it rises exponentially. Okay, so this is perfectly consistent with the story of kind of like an impediment to migration that is removed. And as it removed, the district by district, commune by commune are catching up with their potential, okay, and stay there for the rest of the period. Okay, so this is the S-curve, okay? So we're normalizing to period 0, the point in time in which a commune starts to produce mass migration defined by the threshold of 5 per 1,000, okay? And the pattern that you see here is like the average pattern between the communes, a very, very rapid surge that lasts about 20 years or 15 years, and then a stabilization. In the next figure, we're going to refer to that as the coronavirus figure. We're going to show those curves separating the communes by the period in which cross the threshold into mass migration. Okay, so the solid line, the solid black line, are the early adopters, and the other curves are those who reached mass migration in 95 to 1900, 1900 to 1907, 1907 to 1914. And they all more or less follow the same curve, just like the coronavirus curves that we've all seen recently. Okay, so it's not that. So this is consistent with the story that the late adopters are not necessarily different from their pioneer regions. They are just further behind in the curve. And if World War I never happened and the restrictions in migration never happened, most of the Italian communes would have reached the level of saturation of very high mass migration. We see that distance from the epicenter matters, okay? So in every period, the rate of migration is diminishing as the distance from the epicenter is increasing. And you can see it more clearly. So, okay, we defined arbitrarily what are the epicenters for each of the destinations in Italy. So an epicenter, just like briefly, informally, is a place that has very high migration and no other neighbor with higher migration than his, in the first 4 years that we observed between 76 and 80, if I'm not mistaken. More interesting is the effect of the frontier. Okay, so look at the gray confidence interval. We define the distance to the frontier as the distance to the nearest place that has produced mass migration in the previous period. And you see that migration is basically picking up at every half decade only in the places that are under 200 kilometers from the frontier. And within those 200 kilometers, there is a very sharp negative gradient. The last predictions are the prediction that as distances between two places increases, the similarity in the destination is going to diminish. And this is what you see here. Places that are very close to one another have a very similar pattern of destination distributions. And as you go further away, the similarity is increasing. Another thing that you can see here is that conditional on the distance, the dissimilarity is diminishing over time, which is consistent with many networks, many processes of diffusion coming to cover the entire country, okay? So as time goes by, the migration menu of all individuals in Italy is becoming increasingly similar. All right, so this is all circumstantial evidence that follows from our theory. It could be produced by other theories, although it's going to be hard to produce all of them by one single theory. We still need to show that this is exactly what happens. And we're trying to make one step in this direction by showing really the mechanism, that there is a mechanism of infection from one place to another. Okay, so how are we going to do that? So we're kind of borrowing from trade literature. We're getting to the empirical specification. We want to regress current migration in a given place on a measure of the emission of its neighbors in the previous periods. Okay, so here's the measure that we refer to as emigration exposure. Emigration exposure is basically a weighted average of migration of the neighboring communes, so weighted by distance with a negative distance parameter theta. Okay, and you can think of it as, and to the question, there is kind of like an underlying structure here that assumes what is the distribution of contacts across other communes. And this basically tells you, we assume that the probability of the contacts in the neighboring commune is higher. And this measure basically tells you what is the probability then that a given out of commune contact has migrated, okay? Where contacts are more likely to be proximate rather than far. So, and we're taking the lag of that measure, and we're going to regress current migration on this measure of emigration exposure, and also on lagged on migration, and as well as time fixed effects and the commune characteristics. Okay, so we're going to start, this is clear, we're going to start with the very naive OLS specification. Okay, so coefficient of interest are in the second row. These are the lagged emigration exposure. And what you see, and you can interpret them in terms of elasticities, basically. Okay, so this is the elasticity of your neighbor's lagged migration, just kind of like the plane correlation. We're adding controls in column 2, and then we're adding fixed effects all the way up to column 7, where we have district interacted with half decades effect. It remains very strong. We think that 0.4, 0.3 is we think that it's a very economically significant correlation, but obviously it could be driven by many other things. So the main types of threats that we have in mind is first, spatially correlated causes of emigration. It could be that some places are just inherently more likely to produce migration, and neighboring places are similar to one another. So obviously we're going to have a correlation, a spatial correlation in causes of migration, a correlation that is static. We're going to take care of that by fixed effects, but that's surely not enough. Okay. The two more serious worries is that there could be spatially correlated shocks in migration, or that the diffusion that we're seeing is actually a diffusion of another cause of immigration and not the networks themselves. For example, you can think about diffusion of industrialization or demographic transition or whatever factor causing migration that you might have in mind, okay? Now, with the later two threats, it's harder to treat, okay? I understand that I don't have a lot of time. I'm just gonna show you here that with the fixed effects, it follows, but the fixed effects are obviously not sufficient. They just leave that this correlation is not driven by factors that are constant over time. So we need to move to deal with the problem of dynamic spatial correlation or diffusion process. Yeah. Okay. So even if I don't have a lot of time, the last thing I want to do is to show you the gist, like the intuition behind our IV strategy. Okay. So the IV strategy works in the cross-section. Okay. So think of the red commune as the epicenter, a place that was the pioneer of migration. And migration is kind of spreading in concentric circles all the way to the left and the right blue communes, who are equidistant from the epicenter. Okay. Now, we could have instrumented using distance from epicenters, but distance from epicenters is not a good instrument because in general, we don't think that distance is a good instrument. And in this particular case, it is indeed, distance from the epicenters is indeed correlated with characteristics that we observe. But what we can do is to use spatial distribution of neighbors as an exogenous source of variation for the time of arrival of networks. So look at the commune on the left. The distribution of its neighbors is tilted towards the epicenter. So more of its neighbors relative to the right commune are going to be exposed first to migration simply because its neighbors are more proximate to the epicenter. Okay? So we can condition on the distance from the epicenter and use as an exogenous source of variation the spatial distribution of the neighboring population, which we think, and we kind of like at least partly confirm that it seems to be exogenous. Okay, what do we do in practice? In practice, it's a procedure that takes place in 3 stages. In stage 0, we're trying to create a prediction of migration conditional based on the distance from the epicenter. Now that's going to be endogenous, okay? The next thing that we're going to do is to construct a synthetic measure of migration exposure of every commune. Now, conditional on any commune's measure, this measure is going to be exogenous. It's only going to be a function of the distribution of the population around it, not of its own distance to the epicenter. And so we're going to use that synthetic measure as an instrument for the actual exposure measure. And then we're just going to run our usual IV regression. Okay. Now, the 0-stage coefficients are just as expected, very strong, but diminishing over time. Okay. Which is exactly the prediction of the diffusion. As we approach saturation, the distance to the epicenter matters less and less. These are the main results. And now you have to look at the top row, the lagged emigration exposure, and pretty much we're getting the same thing, even when we control for interactions of district and half-decades effects. Now, to be clear, the strategy works only in cross-section. So basically, we have an IV with sort of a repeated cross-section. We're not using the panel here, the panel variation, other than that we are kind of like you doing it multiple times. But at least at the cross-section, it works, and we think, I mean, we'd be very happy to hear your critique about it, but we think that it's a relatively clean IV, although it doesn't use the panel data. So the story still follows. That's kind of like the bottom line. We do balancing tests to show that this synthetic instrument is not correlated. So the here we show, I'm not going to get into the details, but we're testing that the distribution of your neighbors and the distance of your neighbors to the epicenters are not correlated with most of the observable variables that matter that we have. The thing that doesn't work is literacy. Obviously, when we run the regressions, we're controlling for everything that we can with half-decade-specific coefficient. All right, we have a bunch of robustness tests that you should not be interested in. The bottom line is that sometimes there is a little bit of significance, but overall, we don't see any problem that is worth reporting. I mean, the same story passes in many specifications. Your neighbor's migration in the previous periods is a cause for your own migration for exogenous regions. Right, so this is our conclusion. We're trying to think where our findings, what is the contribution in those findings? So first, we think it suggests a better understanding of the age of mass migration. We think that if it worked in Italy, it may work in other countries. To be clear, we don't think that there was necessarily a European-wide process of diffusion. The reason why we don't think so is that we said that pioneers and long distance migration, long distance connections are rare, but they're not that rare. And so the thing is not necessarily going to scale up. We don't think, for example, that migration from Germany kind of diffused into Italy. But we do have, I think, a good evidence of existence that many regions in Italy that would be producers of mass migration were muted for several decades until finally they surged, and sometimes to the highest numbers ever observed. And we think that in the case of Italy, this is the first order dominant of when a place starts producing mass migration. And it gives us an answer to, I think, a very important question in American history. Did millions immigrate when they did and not earlier? And why did millions of would-be Americans eventually never migrated because of the World War I and the restrictions that were eventually placed on migration? And we don't have it as a bullet, but you guys are mostly interested in contemporary migration. And we try to think how relevant the findings are for contemporary migration. And it's more difficult because we live in a different world. We know that a lot of migration, or basically migration, almost always takes place within networks. But now it's not a free migration. There's so many restrictions that apply. But I think there is one interesting conclusion that should be kept in mind, that the fact that a place seems to have everything, all the incentives right for migration, yet it doesn't pull migration, like, for example, migration from sub-Saharan Africa into the United States, doesn't mean that there is no underlying pent-up demand for that, okay? So the prediction would be, if we map it to the case of African migration to the United States as opposed to Europe, that once this thing started, the demand is going to be very, very high. Okay, I guess that's about it. So I'm ready to take questions now.
So thank you, Yannay. We have about 10 minutes for questions. So I let Simone take over to allocate the questions.
Okay, so far there is no, Ariell has done a great job, so there are no unanswered questions. So all the panelists.
Can I suggest something for Yannay to speak about briefly that I think will clarify a little bit?
Yeah.
I think it would help if you kind of made the analogy to the epidemiological models and the cancer, like the location-specific cancer type models versus infectious disease.
I was going to use that language and missed it, but I think the best analogy to think about the two competing models is like the difference between an infectious disease and cancer, okay? So the traditional view of the age of mass migration is that migration takes place like cancer, in the sense that places that have the potential for migration will spontaneously, eventually, independently of their neighbors, can produce the disease. They don't need contact with people who have already done that before, okay? We know that they do have that, but it's not a necessary condition to jumpstart migration. On the other hand, we think about migration like a flu. You could be highly susceptible. You could have all the incentives, but if you don't come in direct contact with someone who has migrated before you, or if a commune has not come into the cycle of in proximity to the networks of migration, the pioneers are going to be too rare, and they're not going to affect the macro pattern. They do exist, and we know some of them. We think that it really looks much more like a flu, and not like a corona flu that can jump from Italy to New York and from China to Italy, but a flu that passes from one town to the neighboring. And to cover a country like Italy takes about 40 years.
There are a couple of questions from Giuseppe De Arcangelis and Petra Moser. Giuseppe?
Yes, I'll have a question too.
In Italy, there were subsidies to migrate that were in place up to 1890. They were under what was called the Crispi law. Did you take into consideration the fact that maybe some communes were more affected by these subsidies rather than others?
So we don't know, for example, migration to Brazil, which was actually supported by the Brazilian government. So you have all sorts of, sometimes their passage was paid, sometimes they would just recruit workers to work in the coffee and cacao plantations. We're also worried about the phenomenon that we call the padrone, basically people who may not have, who migrate because some boss sitting in New York or in another city in the Northeast sends out to recruit them. But even those cases are over social networks, right? So they're reporting their cousin, they're actually going to work. Overall, the evidence is data. I mean, there is a question of like, you know, can you produce spontaneous mass migration without having a neighboring commune? It could be either by assisted migration, by the support of the Italian government, of Brazilian plantation owners, Italian-American padrones. It doesn't seem to affect the macro pattern. That's basically the conclusion. So, but the answer is no, we don't take that particular subsidy.
I think it's particularly telling that the big increase in migration rates happens around 1900, which is well after that law apparently has gone out of effect. They said it was 1890.
So you went really fast over this one map that, no, you didn't go too fast in other ways, but you went really fast over this really interesting map that showed differences in where these people went. So it seemed like
in their places of,
yeah, so it seemed like people from the south of Italy would go to the US and people from the north of Italy went to the rest of Europe, right?
So let's go over
variation.
That
again. Let me just ask my question.
Yeah.
That is variation that you could possibly use to disentangle your preferred explanation from the others, because economic conditions change differentially in the United States and then the rest of Europe at this time.
Yeah.
So the pull factor shifted more strongly with respect to the US relative to the rest of Europe. And then you can kind of run these two things against each other, and you would expect that relatively your preferred mechanism should be stronger in the south of Italy.
Yeah, so you're absolutely right. And so basically, let me just go briefly over this. This is the frontier, half decade by half decades, when the destination is North America. So darker means that mass migration was earlier. This is for South America. And not surprisingly, this is how Europe looks. Okay, in Europe, it really slides down the Alps and then climbing up the Apennines. And we could use it as in principle as a source of identification. Okay, it was harder to do it here because of the fact that we need to impute within province. And that's a problem. Within provinces, we cannot differentiate the destinations. So we would have liked to horse race the different destinations. And the problem is that the neighbors that matter are almost entirely in your province. But we are thinking now about a follow-up paper that will enable us to run counterfactual. And now we're working on how to resolve the issue of competing destinations. So it's a very complex structural problem to resolve. I think it will take us time before the paper is actually there, but there we're actually going to use that as an identification, a source of identification. Yeah.
Tyler, you had a question?
So going back to the epidemiological models, so the side of the coin in these models, you also have people recovering. So the kind of the spread declines over time, right? So if, for example, here, the diffusion or ideas or the knowledge, if your relatives went 30 years earlier, you know, it's less relevant information for you now than if they had gone 5 years earlier. Could you test that idea as well?
So it could be. I mean, Hatton and Williamson claim that the typical time trend of migration is a surge and then a decline. And this is, for example, something that we see in the German migration and in the Scandinavian migration. It took place. We don't see it. We see all the way up to World War I, and there is not a single sign of diminishing migration by then. It could be that, as Hatton and Williamson would predict, that after there is enough time, migration remains steady, the standards of living are going to be improved, but we just don't see it here. It's a possibility, but doesn't show up within this period. if there is one last thing I would like to show for migration scholars is this map, okay? Which I didn't mention that, but this is the map of emigration to North America and Italy when we are almost reaching saturation. And everyone who knows the Italian map should be familiar with that, because this is almost exactly, not exactly, but it's very much a topographic map of Italy. Italian migration came from the mountains and not from the plain. The Po Valley is pretty much absent when very near areas in the Alps are producing the largest number of migrants. We're also seeing these differences in, for example, between Calabria and Puglia, two neighboring regions. One is plain and one is hilly. And when we look at the data, we really see that.
Don't you think it's a problem for you?
In what sense?
Because if you started saying the standard theory is about the characteristics of the topography would seem to be an important characteristic.
Yeah, so to be clear,
that you would control for common shocks and diffusion of shocks, which would seem to disseminate to similar characteristics. So actually the fact that it confounds with the topography may not be so good news.
Yeah, so I think it's baked into a theory. It may produce challenges to the identification in ways that we don't really see. But this was kind of resolved when you did fixed effects, and also in the balancing test we saw that the instrument is orthogonal.
The question I wanted to ask.
We also control throughout for elevation, but I think the bigger issue is that, Hillel, it's not contrary to the theory that we should see this converging to a topographical map. In fact, it's exactly consistent with the theory. The idea is that
with the other one.
No. So that's the thing. The distinction between the theories comes in the early portion of the migration period. So the idea is by the end of the period, once all the communes have reached saturation and essentially everybody knows the prior migrant, this diffusion process isn't important anymore. What matters are the incentives to migrate there, and topography is a kind of a good first order approximation of the incentives. In the early period, though, Yannay, if you'll pan back, the topography is no different in the early period. The topography is exactly the same. And yet what we see is that there really is this very important geographic component, and it's spreading. So the idea is early on, the model predicts that topography should be kind of not predicting as well, because what matters is whether or not people are linked. But by the end, by 1914, when the south of Italy is entirely saturated, basically everyone knows a migrant, has the option to migrate if they wish, then we expect that it really should converge to a state in really the two models essentially converge to one another at that point.
So that was actually one of my comments, not so much a question. Maybe in terms of motivation, you're pushing, maybe just in the slides, maybe it's not the case in the paper, that you're pushing a bit too far the distinction, the opposition between the two. I would see the diffusion story as more a refinement on the network story rather than a totally different thing. I think it's an incremental and important change, but it's not completely a change in nature of the explanation. So
we think as one nested inside the other. So you can write the old model.
Because think of the network story that partly go through marriage, and marriage would be, extensions of networks to nearby communities and so on. So you can easily reconcile the two, I would say. Then I had a question really about what you do about the common shocks and the diffusion of shocks. I was just interested to know whether you considered applying a grid analysis or what else you're doing. A grid analysis that would, separate, create artificial districts. This is something we do with Toman in our paper on Moldova. And this is supposed to take care about spatially concentrated confounders such as shocks.
Yeah, that's actually an idea that we didn't think about, and I think it could be like a very good robustness check just to show that, because there is a variation in the size of the districts and the communes. So districts in the north of Italy are tiny, and in the south they're very large. And Now, in terms of the exposure measure, it's not going to be very sensitive to that. Other than some frictions, it's kind of like immune to how exactly you define the geographic units. But there is going to be a difference, and I think it's actually worthwhile checking. So thanks for that.
I need to ask Simone if there are any remaining questions because we are slightly over time.
No, I think it's.
And thank you, Yannay and Ariell, for the presentation, and Simone for the organization, and all the participants. If you want to say something about the next seminar, Simone.
Next seminar is Mushfiq Mubarak from Yale with a paper on a Bangladesh to Malaysia migration lottery, and then Anna Maria Maida, Giovanni Peri. So everything is online on our website. Thanks a lot to all of you, and have a nice week.